Hi everybody, very warm welcome to Vedantu JEE English channel. This is me, your master teacher Nabamita Ma'am, and as it is written on the board, you can see that mole concept, redox and equilibrium, three of the most basic and fundamental chapters. Ideally, Wasim sir has taught you so much of these chapters that I should not even be revising. But guess what? These are the three chapters whose applications you keep seeing that they are sneaking up to you somewhere or the other, right? We need these chapters because these chapters do come elsewhere in our books as well, okay? And one more thing is that if you complete these three chapters, okay, if you complete these three chapters, what are you going to get? You are going to get around 9%, in fact 10% of your whole chemistry paper will be solved from here. So today's session is going to be a little fast because ideally these chapters are so big that if I have to explain everything, it will not be possible to finish it in just 3 hours. So I have all the problems here. I have all the the formulas here. Everything is right here. We're just going to go rush through it and we are going to see the end of the light. Yes, I mean light at the end of the tunnel. Alright, so let's begin everybody. Are you all with me? Can I see some la la la? Also please call up your friends, yeah? Chalo. Let's begin guys. Let's begin. Shall we? We will start with this. We will start with the first chapter, that is mole and equivalent concept. Come on, quickly call up your friends. Call up your friends. Call up your friends. Thank you so much, Rivatsan. Thank you so much. Yes. Hi Neha. Hi Blessy. Hello. Hello. I can see a lot of students here. Amazing. Did you guys did not have lunch or what? You guys did not have lunch? I see a less number of students today. Or are you done with this chapter? So you're already prepared with this chapter, is it? Yeah? Okay, good afternoon guys, good afternoon. No, then call up your friends. What happened? Share it with your friends also. Yeah. Okay, study first. Yeah, absolutely. We will talk about the formulas and everything first, and then I will teach everything, bacha. Acing. Did you have lunch? No, yeah. I was preparing for the session and I forgot. I think I'll have lunch after the session. All right. No more talks. We will talk at the end of the session. Let's begin. Okay, let's begin. So mole and equivalent concept. Yes, now we have seen that at least one question will definitely be there in your session, be there in your paper. So here, the first thing that we have to know in this chapter is number of moles. Yes, number of moles. How do you calculate number of moles, my dear student? As we know, it is given mass, whatever is the mass that is given in the problem. We will be solving problem also, so you will get to see the the practical application of these formulas. Yeah. Divided by molar mass. Molar mass, everybody knows how to calculate. Yes, you will be given a molecule, just calculate the molar mass of it. Yep, okay. Apart from that, the second formula for today is number of moles is equal to, you can also calculate number of moles in a different way, which is given number of particles divided by Avogadro number, which is 6.023 into 10 to the power 23, right? I don't have to say that again because everybody knows it. Yes, everybody knows it. Very basic, very simple. Moving on from here, okay, some more formulas here. The number of atoms. How do we calculate the number of atoms? Okay. You will be given mass of atom. Yes, you will be given the mass of atom in the question. Yeah, Tamil tere aaja. I don't know how to speak Tamil. That's the only thing that I know. Okay. Anyway, divided by molar mass of atom again into Avogadro number. Yeah. Okay. Now, the number of molecules. If you have to calculate the number of molecules, what will you do? You will once again given mass of molecule divided by molar mass of molecule and multiply it with Avogadro number. Understood? This is clear, everybody? Do we all know this? Absolutely. We know this, right? We know this? Yes? Yes. Say again. What? Say again. This is the formula. Chalo, I'll show you a chart. I'll show you this thing. You know Bengali? Hai, I am a Bengali. My mother tongue is Bengali. Why won't I know it? Chalo, acha. Now, here is how will you calculate mass in grams or the number of molecules, right? There are two things that you can do. number of moles, yes, if you have to calculate the number of moles, you can either calculate in mass in grams, yes, or it can be number of molecules. Here, as you can see, if number of molecules is given, then this is how you calculate. If mass in grams is given, then this is how you calculate, okay. Number of moles is denoted by the small letter n, which is equal to W divided by mm. What is mm? Molar mass, right? Right? Yes? Okay. So mass in grams, W. Yeah. Okay. This makes sense. This makes sense, everybody. Makes sense or nonsense? Everyone. Understanding. Great. Now, n. Again, small n is equal to capital N divided by Na. What is Na? Avogadro number. Avogadro number. Do not confuse it with anything else. Huh? No sodium, nothing. This is only Na, number of Avogadro number. Okay? Huh? So, no. I'm talking about capital mm only, na bacha. Rex, don't confuse me. I'm saying it correct only. Yeah, capital mm is molar mass, huh? So here capital N for Nabamita, N, capital N, not M, N. N is what? N is number of molecules. Maybe it will be given to you in the question paper, okay? All right, yes. Now, how will you calculate capital N? Let's say that it is not given to you. If capital N is not given to you, then what will you do? You will calculate is N is equal to W divided by molar mass into Na, which we just saw some time back. Yes? Okay. Now, here is a cheat sheet. Here is your cheat sheet. Everybody focus up here. Everyone focus. Focus, everybody. Yeah. Take a look at it. Now, let's say that mole is given to you. From mole, you have to find the number. From mole, you have to find the number, capital N. Then what will you do? Multiply it with Avogadro number. If number is given in the question and you have to find out the mole, then what will you do? Divide it by Avogadro number. Understanding? Making sense? Note it down. Note it down. By the way, I hope that you are sitting in the session with your pen and paper. Huh? Please sit with a pen and paper. Alright. Also, thank you so much for all the likes that you have given. Yeah, thank you so much. If you're liking the session, don't forget to hit the like button. It will really make me happy. Make my day at least. Yeah. Chalo. Now, if you are given mole, you have to find the volume at STP. What is STP? Standard temperature and pressure. Because we know that gaseous state, what happens? Gaseous states, they can change the volume, right? They can change the volume with a little bit change in temperature and pressure, because volume is dependent on the temperature and pressure. Hence, standard temperature and pressure, okay? If you have to find the volume at standard temperature and pressure, what will you do? You will multiply it with 22.4 liter. By chance, volume at STP is given and you have to come back to the mole, then what will you do? 22.4 liter. Yes, divided by 22.4 liter. Akash, STP, I just told you. NTP, as we go along, I'll tell you. Don't worry, okay? Now, from mole, if you have to find out the mass, what will you do? Then what will you do is, if you have to find the mass, then multiply it with molecular weight or atomic weight. Now, from mass, if you have to go to mole, then either you will divide it by molecular weight or divide it by atomic weight, whatever is given to you. Coolish? Cool, everybody? Makes sense? Hariom Tripathi, number as in number of atoms, number of molecules. Yes, that is what is they are asking, okay? Shortcut notes, this. Write it down while I'm telling you. You want me to? Okay, chalo. But I'll be providing you with a PDF, no? Anyway. I'll be providing you with the PDF as soon as the class ends. So don't worry about it. This PDF will be provided. Now listen to me and try to solve the questions while I provide you with the questions. Okay? Yeah. Don't worry about it. Chalo. Moving on. Here, let's solve a problem. You have to calculate the volume of carbon dioxide gas produced at STP by complete combustion of 560 gram of octane. Try solve it. Try solving it. Come on. Go ahead. Go ahead. The options are also there. I'll show it to you how to solve it. But till then, you at least try. Try. Yes, Robin. Yes. You know that. STP by complete combustion of 560 gram of octane. Go ahead. Try. First, write down what are the given ones. Then you try to solve it. Yes. Then you try to solve it. Chalo. So basically, I'm actually standing on a platform today As you know that this is my ideal height and this is me standing on the platform. To move around is a little difficult today because I might just trip and fall over. Oh, Rex Knight, do I really have to tell you that also? PDF milega, yes, PDF milega. Octane, you are asking me, octane? That's why I look taller today. Chalo, okay, let's try to solve it now. So what is octane, guys? Okay, C8H18, that's your octane, yes. Now we will write down the equation first, isn't it? We will write down the equation. Understand, this is not board, we have to do shortcut. Now, because I said that these 3 chapters are so very big, if I had to solve this, if I had to write it down and solve this, guess what would have happened? We would not have completed this session in 3 hours, but rather it would have taken 6 hours, and we don't have so much time. Time is of essence right now. So here is the solution that is already done for you, and I'm going to just explain it to you. So C8H18 plus 25/2 oxygen we will take, which will give us 8 CO2 plus 9 H2. Now, 560 gram of octane that is given to you, right? Everybody, can you all see it? 560 gram of octane is given to you in the question. In the question right here it's given. So let's write that down. W octane is equal to 560 gram. Now if we have to find out N octane, what do we have to do? 570 gram, that is the given mass, divided by the molar mass, 114 gram per mole. This equates to 5 mole. Understanding, guys? Understanding? Yes? Is this getting clear? Let me stop me whenever you are not able to understand, huh? Stop me whenever you are not able to understand. Let me know, is this understood? Yes, bacha? Neat students can also watch it. It's almost the same. Hai na? Ha. Now, so we understand that if 1 mole of octane gives you 8 mole of CO2, as we can see in the reaction, right? Yes? Correcto? Great. 8 mole of CO2. Now, because here we found that this is 5 mole, that means that 5 mole of octane will give us how much? 8 into 5. 8 into 5. Should we remember that equation? No, bro. You must, I mean, you have to know the equation, right? Yes? You have to know the equation. Chalo. So, 5 mole of octane will be 8 into 5, which is basically 40 mole of carbon dioxide. Correct? 40 mole of carbon dioxide will come out. So, NCO2 is 40 mole. That means then VCO2, what are they asking? They are asking calculate the volume of carbon dioxide. So, volume of carbon dioxide will be NCO2 into 22.4 liters. 22.4 liters. I just showed it to you, remember? See, 22.4 liters. We have to find the volume at STP. Yes. So, 22.4 liter, when we multiply, what do we get? We get 896 liter. That means option B is correct. Is this understood? Is this understood, my dear student? Do we now know how to calculate it? If this kind of questions come in your exam, will you be able to do it? Yes? Awesome, Anushri. Awesome. Very nice. Huh. Yes, yes, Srivatsan. This is clear. Do you want me to just easy peasy biryani is tasty? Yes? Easy peasy biryani is tasty. Shaku, keep it 22.4 only, no? Because that's the cheat sheet that I just gave it to you. Isn't it? I just showed it to you, see? 22.4 liter. 22.4 liter. Hai na? So do this, huh? No, Viram, I don't think so. Wasim sir is there, no? He will be teaching you, okay? Acha. Easy peasy, biryani is tasty. Okay. So, oh, that's what is EPBT. Ah, you guys came up with a short form. I was thinking yesterday that what is EPBT? A lot of students were writing EPBT. Thank you so much. Anyway, moving on to the next question, guys. Next question, everybody. Focus up, focus up, focus up. Huh. So, calculate the number of moles of O atom present in 3.2 gram of Na2SO4.2H2O. Molar mass is already given, okay? Molar mass is already given to you in the question paper, in the question. So, molar mass of Na2SO4.2H2O is 178 gram per mole. What is the approach here? What should be our approach? How are we going to do this question? Any idea, guys? Any idea? Batao chalo. I hope you know this. Acha, guys, why are so many students watching but you guys are not liking? You don't like me or what? Huh? like the session? No. I'm telling you, otherwise Vedantu will think that I'm not a good teacher. If I'm not a good teacher and you want to punish me, then sure. But if you think that I'm teaching you well, then like it. Yeah, thanks. Thank you. Thanks. Chalo, let's look at it, okay? Let's look at it. So, okay. So, one molecule of H2SO4 will give you 2 atoms of H atoms, 2 atoms of hydrogen, 1 atom of sulfur, 4 atom of oxygen. Huh? 1 mole of H2SO4. Why is it H2SO4? It shouldn't be H2SO4. It should be Na2SO4. Should be Na2SO4. But chalo, theek hai. You can still understand from this, okay? It shouldn't be H2SO4. It should ideally be Na2SO4 dot 2H2O. 1 second, guys. 1 second. 1 molecule of H2SO4 shouldn't be, yeah, it should be Na2SO4. Correct. 2 moles of 1 molecule of H2SO4, 2 moles of H atoms, 1 mole of S. Okay. 3.2 divided by 178 mole. Just a second. Just a second. Yes, there is an error. There is an error. Ha, there is an error. Yes. Chalo. What we're going to do is we will write Na2SO4. That means here it will be Na. Alright. This also we will Na2SO4. Yes. That means here also it will be Na. Alright. Now. N of Na2SO4 dot 2H2, what will it give you? It will give you 3.2 divided by 178 mole. Okay, 178 mole. Where did we get 3.2 from? Where did we get 3.2 from? The 3.2 is from here, right here. Okay, and then 178 we will have to calculate. Yes, do we know this? Do we know this? Yes. Okay, all right. Now 1 mole of Na2SO4 dot 2H2O is giving you 6 mole, okay? It will give you 6 mole of O. That means that this value, we will take this value, we will put it up here. So 3.2 divided by 178 mole of Na2SO4 dot 2H2O. How much will it give you? What do we have to do? Because we know that 6 mole of O atoms it is giving. So what we will do is 6 into 3.2 divided by 172 mole. How did we find that it is 6, guys? How did we find that it is 6? Huh? How did we find that it is 6? Because here see 4O and another 2O. So 4 plus 2, 6. Hai na? 6. Hai na? Yes. Alright. I mean 172 is already given, but if it is not given, let's assume that if it is not given, then what will you do? You will have to calculate. No, bacha? So I'm just telling you that you have to calculate it. Chalo. So what you will do is 6 into 3.2 divided by 178. Just use the calculator and find it out. The correct answer is 0.107 mole. That means that option A is the correct one. Okay. Alright. Yes. Got it. Clear? Clear? Understood? Once again, it was very simple, very easy. Very simple, very easy. Yes. Thank you, Kishore. Thank you. Said it in Oriano. Understood. Great. Chalo. Moving on. Now let's understand the percentage composition. Which your question is this, Shabib, that I haven't written, but it has come. Okay. All of the questions that I'm doing here are actually previous year question. You can search it on the internet if you still have some doubt. Okay. All right, Shabib. Check it out, bacha. Chalo. Now percentage composition. Okay. Percentage composition of the compound is basically the relative mass of each of the constituent element in 100 parts of it. That means, okay, why are we multiplying? Shaku, I just taught you, no? Would you mind just forwarding it just going back a little bit and watching it again? Do that, you will understand. Hai na? Do that, you will understand. Acha. So what is percentage? Acha, let's say that I want to, okay, out of 100 marks, if I get 85 marks, what will be my percentage? 85%, right? 85%, yes. So what is written here? What is the definition? The definition says that percentage composition of the compound is the relative mass of each of the constituent elements in 100 parts of it. Out of 100 parts, what is the relative mass? That's it. So if out of 100, if I get 85, then the percentage will be 85%, right? Very simple, very easy. Anything to explain here? You all know how to do this, right? So mass percentage of an element, how will we calculate this? Mass of that element in 1 mole of the compound divided by molar mass of the compound multiplied with 100. That's it. That's it. Yeah? Very easy. Okay. Now, percentage composition may, see what you can do is percentage yield we can find out. Why are we finding percentage yield? What does yield means? The word yield means produce. What is the produce? Now, let's say that I expected actually to get 95 marks in chemistry out of 100. Where did I get it actually? Theoretically, in my mind, I thought I expected to get 95. But there were some errors and something, and 10 marks just went into thin air. Okay? Yes? 10 marks just went into thin air. So actually, what did I get? I got 85. So 85 divided by 95 into 100. That's my percentage yield. That's my percentage yield. Easy peasy biryani is tasty. That's it. That's all that the formula says. Moving on from here, percentage purity. Now, only example that comes in my mind is metallurgy. Let's just say that I have dug out a ore. Yes, I have dug out a ore. I found a big patthar, that is a stone, found a big stone. Now, in that stone, what is the amount of gold? Pure gold. What is the amount of pure gold, the mass of pure gold that I found from the mass of impure sample? So, you have to weigh the whole stone. Out of that stone, what is the gold, pure gold that you got into 100 is equal to your percentage purity. I mean, that's the one thing that came in my, on top of my head. This is the example that came. So I hope this is understandable. Makes sense? Nonsense? Yes? Makes sense or nonsense? Okay? Alright, chalo, theek hai, makes sense. I hope that it is making sense. Now, let's do a question. Let's do a question here. Okay? So, 5 gram of H2SO4 sample exactly requires 4 gram of NaOH for complete neutralization. So, calculate the percentage purity of H2SO4 sample. How will you calculate it? Even the reaction is also given. So, once again, very easy question, right? H2SO4 plus 2 NaOH will give you 2 Na2SO4 plus 2 H2. That means H2SO4, okay, 98 gram. Na2SO4 80 gram plus 2H2. So we can say that 80 gram of NaOH requires 98 gram of H2SO4. For the formation of 80 gram of Na2SO4, we require 98 gram of H2SO4. Does that make sense? It does make sense. So if I want to find out 1 gram of NaOH, for the formation of 1 gram of NaOH, what is our requirement? Yes, what is it that we will require? We will require 98 by 80 of H2SO4. This is the amount that we will require. Now, I want to find out 4 gram of NaOH. What is the requirement here? For 4 gram of NaOH formation, how much is the H2SO4 that I require? 98 by 80 into 40 into 4 is 4.9 gram of H2SO4, which is 5 gram, right? So that means my percentage, almost 5 gram, but not really 5 grams. So percentage purity is 4.9, and in the question it says that it is 5 gram. So 4.9 divided by 5 into 1000 is 98%. Again, we understand this? Do we understand this? If this is the case, then what is our answer? Our answer is option D. Hai na? Hai na? Simple? Very simple, guys. Yes? Are you guys trying to solve it or not? I hope that you all are trying to solve it also, huh? Done. Okay, great. Okay. Now, let's go to mole fraction. As the name suggests, fraction. It is fraction. So, how do we denote it? We denote it as chi. This is not x. Don't call it x. It is chi. So, chi is basically the moles of solute divided by total moles in solution. Okay, total moles in solution. Srivatsan, I'll explain it again later, or you can just, go back a little bit, watch it again. Okay? Yes? Now, so what do we have? We have moles of solute divided by total moles in solution. Now, how will you find the solution? How will you find the solution? Obviously, N solute plus N solvent, that's what gives us chi, hai na? Now, if at all, let's say that A, B, C are different solutes and solvent. Let's say that lemonade, you have made lemonade. Now, in lemonade, what are your solutes? You have salt also, you have sugar also, hai na? So, what will you do? What will you do? You will have to do chi A plus chi B plus chi C. Now remember guys, in mathematics, we have learnt that the fractions must add up to 1, right? The fractions have to add up to 1. So summation of all the chi will have to give you 1. It always has to give you 1. Yeah? Moving on from here. So let's go to molarity. I tried to make a story out of it, but it's so many formulas that it's not visible. What's not visible? This is not visible. Summation chi is equal to 1. Is this not visible? I can see it. Do you want me to write it down somewhere else? Anyway, so molarity. Okay, let's find out that molarity. Everybody knows this formula, hai na? Yes? Yes. So molarity, capital M, yes, denoted by capital M. Molarity, molality. Molarity, capital M, is basically W into 1000 divided by molecular weight of solute into V. Okay, molecular weight of solute in weight of solute into V in milliliter. Okay, in milliliter. Molality. What is molality? Molality is basically number of moles of solute divided by mass of solvent in gram. Difference, guys, difference. Note down the difference. Molecular weight of solute, mass of solvent in gram. Okay, here there is molecular weight of solute and here this is mass of solvent into 1000. All right, done deal, done deal. Great. Now let's understand what is equivalent weight. What is equivalent weight? Chalo, let's try to understand with an example. Here, whatever is written, it's actually really big, isn't it? It's very big and we might not be able to understand it. So let's take the example of hydrogen plus oxygen will give us H2O. Hai na? So if I write down the equation, let's say that the equation becomes H2, okay? Let's say that the equation becomes H2 plus half O2 will give you H2O, isn't it? That's my reaction. That's my reaction. Am I right? Yes, that's my reaction. Everybody, you can read it also. You can read it, but let me try to explain this first. Hai na? Let me try to explain this first. So that means that 2 gram of hydrogen, plus 16 gram of oxygen will give me 18 gram. Yes? Where do I write that now? That means that, okay, let me change the color of the pen and write it down. That means that 2 gram of hydrogen plus 16 gram of oxygen will give me 18 gram. This I can simplify and I can make it as 1 plus 8 will give me 9 gram. Am I right? Yes, I can simplify it and I can write that. That means, now do you also notice that hydrogen, yes, do you also notice that hydrogen has basically +1 charge here? Yes. Oxygen has 2 minus. Yes, oxygen has 2 minus. I can say that hydrogen is basically +1 here. Oxygen has -2. And if I would have taken H plus Cl minus, then what would have been the charge here? What would have been the charge? It would have been Cl minus. Yes, -1 charge. Okay. Now read it. It says that it's a very old, like a very traditional, definition. So we don't really have to read it, but just for your explanation, just so that you know the concept behind it, I'm going to teach you here. Okay. So the number of parts by weight of it, that we're talking about equivalent weight. Okay. So the number of parts by weight of it that will combine with or displace directly or indirectly. Let's just consider it to be 1 part by weight of hydrogen, 8 part by weight of oxygen. Do you notice? 1 part of hydrogen, 8 part of oxygen, 35.5 parts by weight of chlorine, or the equivalent parts by weight of another element. One more example. Let's talk about it, guys. What if I tell you that go to a restaurant and order something? What if I tell you that, hey guys, go to a restaurant and order something. Now, if you go and order, let's say that Blessy, okay, Blessy is telling me drink water, I will, bacha. But let's say that Blessy goes and asks for 1 plate of momo. Now, 1 plate of momo that she's asking for, maybe it has what, 7 to 8 pieces of momo, right? And now let's say that Kishore goes and asks for 1 plate of noodles. 1 plate of noodle will be this much, isn't it? But both of you ask for one plate only. Both of you ask for 1 plate, but do you notice that it is different for both of you? It is different. So the same way here also, equivalent weight also depends on reaction to reaction. Yes, equivalent weight also depends on reaction to reaction. What was our equivalent weight? Both of you ordered for 1 plate, but it was different for both of you. Here it was only 8 momo and here there was a heap of noodles. Yeah, got it? Understood now what is equivalent weight? Understood what is equivalent weight? This does not make sense, a lot of it. When you read it, you'll be like, what is it? But this example, I hope it makes sense. Yeah, this example, I hope makes sense. So equivalent weight is basically your molar mass divided by valence factor. What is valence factor? We will talk about it. Yeah? You don't know what is momos, chalo, koi baat nahi, theek hai. You know noodles, Shezwan noodles, you know, and biryani you would understand. When you ask for a handi of 1 plate of biryani, that will probably come in what? Come in that, you know, that mud, this thing, hai na? That mud pot. It will come in that mud pot. Whereas the plate of noodle will come in that circular thing, but both of you have asked for one plate. Understand? Same thing, but looks different. Exactly. Chalo, now let's just read this. Equivalent weight of any substance, it depends on the reaction which it takes part. I exactly told you the same thing. It depends on the reaction you take part. Now, isn't it also possible that let's say that you have ordered momo from a different place altogether today. Today you wanted to try somewhere else, so you ordered momo from a different place. And maybe this new fellow is giving you 5 momos. Okay, let's say that you go to Taj. You go to the Taj Hotel, yeah, Taj Vivanta, Taj Hotel. Once you go to the Taj Hotel and you ask for momo, they will give you 3 pieces of momo. They're like, that's it. 3 pieces of momo, 1 plate, 800 rupees. Come on, bring it on. But if you order it from that street side shop, he will take 80 rupees and he will give you 8 pieces of momo also. 1 plate, both the places. You have asked for 1 plate only. But it depends on where you are asking for it. And exactly the same way here also, equivalent weight of any substance depends on the reaction in which it takes part. Moving on. Equivalent weight is also a relative quantity, so it is unitless. It is unitless, absolutely unitless, okay? Alright, when equivalent weight of a substance is expressed in grams, it is also called as gram equivalent weight. By any chance, if you see in your question paper that equivalent weight is given in gram, then understand that that's your gram equivalent weight and not just equivalent weight, yeah? Cool? Understanding, guys, is this clear? I hope that this example made it simpler. Did this example make it simpler, guys? Yeah? Alright, chalo. Moving on from here then. So, how to calculate valence factor? I'm so sorry. Yeah. Every time I notice from Google Slide to when you download it to PPT, it just changes this. You know, this happens always. Anyway, how to calculate valence factor? Okay, valence factor. Note this. This is important. Yeah, this is important. There will be various this thing, but this is your cheat sheet. This is your cheat sheet. For acid, number of H plus, obviously. For base, number of OH minus. Ion, magnitude of charge on ion. If it is salt, total positive or negative charge furnished, that is yielded by 1 molecule of salt. Hai na? Yes. Now, if it is OARA, oxidizing agent, reducing agent, yeah, OARA is oxidizing agent or reducing agent. So, number of electrons lost or gained by a molecule of oxidizing agent or reducing agent. Yes? Yup. No, Kishore, we will come to the N factor. We'll come to the N factor. This is your valence factor, hai na? This is your valence factor. Now, in case of a redox reaction, can you explain H3PO3? Chapter, focus. Now, in case of redox reaction, okay, in case of redox reaction, now understand this, hai na? For third one, which one? Ion. Ion, bacha. What is an ion? What is an ion? Na plus is an ion, Cl minus is an ion, SO4 2 minus is an ion. See, magnitude of charge on ion, 2 minus, 1 minus, plus 1. These are the magnitude of charge on ion. Understood? Yeah, understood? Okay. Moving on, okay. So in case of a redox reaction, let's say that you have a redox reaction, isn't it? 4. Salt. From a salt, what is the total positive or negative charge that is furnished by one molecule of salt? If you take a salt, what is the total positive charge or the negative charge that is furnished by one molecule of salt? Okay, alright, from one molecule of salt, what is the total positive charge or the negative charge that you are getting out? Hai na? Got it? Chal. Now, in case of a redox reaction, if we take a redox reaction from the oxidation number, N factor, here comes your N factor, okay? N factor of oxidizing or reducing agent is basically the change in the oxidation number per molecule. Shall I take an example? Shall I take an example? Yes? Chalo, let's take an example, everyone. Valence factor of KMNO4. This is important. It does come. It does come in your exam. This is a little important. So listen to this, okay? Listen to this. Valence factor of potassium permanganate, it is different for different medium. In case of acidic medium, what happens? KMNO4, this one right here is in your +7 oxidation state. Am I right? Am I right? Yes. KMNO4 right here, this one is in +7 oxidation state. From here, in acidic medium, it becomes Mn+2, that is +2 oxidation state. So what is the change in the oxidation number, my dear student? The change in the Viram, the change in the oxidation number of Mn is C, +7 -2. When you do this, you will be getting 5. You will be getting 5. So the N factor of KMNO4 in acidic medium is answer 5. Now what if I take a basic medium? What if I take a basic medium? If I take a basic medium, do you think that answer will be same? Not at all. If I take a basic medium, then what happens here is KMNO4, once again, here it is in +7 state. But in basic medium, it becomes K2MnO4. Okay, that means that it is in +6 oxidation state. So what is the N factor here? +7 -6 will be giving you 1. So the N factor of KMNO4 in basic medium, my dear student, is 1. But if it is neutral medium, once again, +7 oxidation state here. Now MnO2, that means here it is in +4 oxidation state. Here it is in +4 oxidation state. So the N factor of KMNO4 +7 -4, answer is 3. Is this clear, guys? Is this clear? Hai na? Now shall we do some questions? Let's try to do some questions. But before that, let's also solve normality. What is normality? Normality is basically the number of gram equivalent. Remember, just some time back only we did gram equivalent. Yes, equivalent weight. Equivalent weight, if it is given in gram, then it becomes gram equivalent. Yes, divided by volume of the solution in liters. Okay. So if the number of gram equivalent are defined as number of gram equivalent is equal to weight of solute in gram, divided by equivalent weight of solute. This is how you can find out if it is not given. If it is not given, this is how you are going to find out. So normality is equal to weight of solute in gram divided by equivalent weight of solute. You can write it like this, into volume of the solution in liter. This becomes our formula. Okay, this becomes our formula. Now the normality equation, okay, which can be used to estimate the volume of a solution needed. What is the equation that you need? Okay, that you need. Viram, I hope that you will be able to find it out on your own, sweetheart. I have just showed you how to do it on your own, or just wait up, let me find out the questions. Okay, let me fetch the questions, we will do it. Because I have explained the concept, I expect you to do it on your own. Okay, now, so the normality equation which can be used to estimate the volume of a solution needed to make a solution of different normality is basically initial normality. You will take N1 into initial volume, which should be equal to final normality into final volume. That means a very simple, very easy equation that we know is basically N1 V1 is equal to N2 V2. This seems familiar? Does this seem familiar? Do we know this? We have seen this. We have seen it in our exam. We have seen it in our paper. We have seen it in our NCERT book as well, right? Exactly. That's the one. That is the one. Okay. Now, What is the relation between normality and molarity? Okay, what is the relation between normality and molarity? Normality is basically molarity into molar mass, yes, divided by equivalent mass, okay? Or normality is equal to molarity into basicity, molarity into acidity. Yes, acidity, basicity, that much we know. For NaOH, OH minus 1 is the basicity. H2SO4, 2 is the acidity, right? We know this. Okay, simple, very easy. Now, question. Everybody focus up. I need you all to focus here, okay? So, 29.2 W by W, that is weight percentage solution of HCl, okay? D of solution is equal to 1.25 gram per mole, occupies 8 milliliter volume. You have to calculate the final volume of the solution where concentration becomes 0.4 molar on dilution. How are we going to do this? How are we going to do this? Come on. This is exactly from what we just learned, okay? From what we just learned. So today there are a lot of questions. I heard you loud and clear from yesterday's session that you need more problems. So here we go. Tell me, guys. Yes. What should be our approach? You find that out. Till then, I'm going to drink some water. Good, Kishore. Good. You found the approach? Chalo. Let's solve. Let's solve. Yes? Okay. So basically what we have to do is, see, M1 is equal to 10 into, okay, 10 into 1.25, that's given to us, into 29.2, that is also given to us, divided by 36.5, okay, which is equal to, if we calculate it, we will get 10. Now once again, 10 into 8 it is given here, is equal to 0.4 into V, okay, 0.4 into D. So V2, if you calculate this, you will be getting 200 ml. You'll be getting 200 ml because once again, what we just learned, Kishore, you are absolutely right. Just like how you said N1 V1, like that we can also do M1 V1 is equal to M2 V2. Clear? All right? Yes? So that means our option A becomes correct. Option A becomes correct. I understand that today's session is going to be a little boring because there are so many formulas. Even if I try to tell you a story, it will still not make sense. It will still not make sense. These 3 chapters, to be very honest, growing up, even I hated them, didn't like them so much. So teaching it becomes a little more difficult for me. Teaching it becomes a little more difficult for me, hai na? So anyway, okay, it's fine. For me it is. I don't like these chapters. Anyway. Alright, calculate the number of gram equivalents in 50 ml of 0.5 N NaOH aqueous solution. Okay, very easy, yeah. This is very easy. So, gram equivalent we have to find. That means N into V in liter. So, 0.5 N is given into 50 is given divided by 1000. So, 0.025. That's it. Easy? Yeah? Easy? Great. Chalo, moving on. Now let's understand the limiting reagent. Okay, limiting reagent. How about let's try to make a hot dog. Let's try to make a hot dog. Okay. So if I try to make a hot dog, let's say that I have 1, 2, 3, 4, 5. 5 sausages I have. Okay. How much do I have? I have 5 sausages. Can you see it here? Can you see it here? 5 sausages. Right? But how many buns do I have? I have only 4 buns. 1, 2, 3, 4. I have only 4 buns. Yes, I have only 4 buns. So 4 buns and 5 sausages. How many hot dogs will I be able to actually make? How many hot dogs will I actually be able to make? 4 only, no? Who limited this? Who was the one who stopped me from making 5 sausages? I mean, who was the one who stopped me from using up all the 5 sausages? It's the buns. The buns stopped me from making 5 hot dogs. And that is why I have 1 excess reagent. I'll keep this in my almirah. I'll keep this back in my fridge, isn't it? this bun, this sausage, I'll keep it in the fridge back again, but this is what I get. This is what I get. I initially thought, I expected that I'll be able to 5 buns, wow, 5 sausages, wow, I'll be able to make 5 hot dogs. But later I found out that my expectations did not come out to be true. I could only make 4 hot dogs. So this becomes my limiting reagent. Okay, this becomes my limiting reagent. I'll tell you the shortcut also how to find out. Let's try to do this. Okay, are you an IITian? Yeah, I am. I had junior research fellowship from IIT Guwahati. You can also check the chemistry department. You will find my photos there also. Okay, and I did my work in nanofluidics. Yes, so yeah, I am. Okay, now 6 LiH plus 8 BF3 will give you 6 LiBF4 plus B2H6. Now both of them are starting with 2 moles. 2 moles of LiH, 2 moles of BF3 of each reactants. What is the mole of B2H6 that can be produced? Yes. How many moles of B2H6 can be produced? Chalo, let's see. Let's solve it. Very easy. So now we are saying that at T0, when we start the reaction, when we are starting the reaction, I have 2 moles here, 2 moles here, and obviously the products have not started to form yet. The products haven't started to form yet, so I will get 0 product here, 0 product here. But at the end, once the reaction has ended, then what will I get? The reactants will be 0. But here, what will I get is 6 by 8, because 6 and 8 here, so 6 by 8 into 2 is equal to 1.5. Hai na? Yes, and here it is 1 by 8 into 2 is equal to 0.25. Yes, all right. Yes, here again, see, basically the shorter, the shortcut is just see that this is the mole given, this is the mole given, this divided by this. That's it you have to do. That's it you have to do. See, 2 by 6, okay, and here it is 2 by 8. This is 0.25, this is 0.77. So this means this is lesser. Whatever ratio you get lesser, this will be your limiting reagent. The shortcut in your exam, when this kind of questions come, what you need to do is find the ratio. Whichever ratio is less, that is your limiting reagent. Clear? Crystal clear, everybody? Clear hai? Clear hai, guys? Or not? Clear or not? Everyone? Oh, sleeping or what? Napping? Is this your nap time? About to be 3 o'clock, huh? Nap time. Napping kya, guys? Don't sleep. Anyway, so if 8 BF3 reacts, it will give you 6 LiH, right? If 1 BF3 reacts, that means it will give you 6 by 8 LiH. Yes, LiH. If 2 moles of BF3 is reacting, that means it is 6 by 8 into 2, which is equal to our 1.5 LiH. Therefore, LiH is equal to 2 minus 0.15 is equal to 0.5. I think there is a mistake. It shouldn't be 0.15. It should be 1.5. It should be 1.5. 1.5. Okay. Yeah. 2 minus 1.5 will give you. Can you? Yes, Abhirami. Chalo. One more time. Devesh, what are you asking? Do you all agree? What are you asking? I used to be, now I'm not. I used to be, now I'm not. Okay, now I teach here. Explain the problem again. Chalo, let me do one thing. Okay, so what is the question asking? This is a limiting reagent question. Okay, the question is saying that if I have, these are my reactants, LiH and BF3, these are my reactants. Am I right? Now I want you all to interact. Please say yes, yes, everyone. Say yes whenever I am asking you. I want the reaction, I want the interaction so that I can understand when you are not understanding, so that I don't have to explain it from the beginning once again. Guys, yes, okay. So LiH plus 8 BF3, okay, will give you 6 LiBF4 plus B2H6. That's my reaction. Yes, that's my reaction. Now in this reaction, the question says that I have taken 2 moles of LiH and I have taken 2 moles of 8 BF3. So what is how many moles of B2H6? Okay, this is my B2H6. How many moles of B2H6 can be produced? If I take 2 mole of LiH, 2 mole of 8 BF3, how much of B2H6 will I be able to produce? Really, you can't understand what I'm saying. I don't think you guys are in 12th standard. Are you in 12th standard? Doesn't look like, because this is very simple explanation that I'm asking. Basically what they are asking in, let's just say that I have one apple and I have one orange. From these, what is the amount of fruit salad that I will be getting? Easier. One apple, one orange. What is the amount of fruit salad I'll be getting? This is the question. Now, for a limiting reagent, in our IIT JEE paper, we don't have so much time. So what we are going to do? We want an easy way to solve it. Whatever is the mole, yes, the number of mole that is given to you in the question, 2 mole it is given. So what you ideally should be doing, shortcut method is just divide 2 by 6. Just divide it by the coefficient. This is your coefficient, just divide it. Number of moles that is provided in the question, just divide that by the coefficient. That's all. When you do this, check it out. Tell me now. Okay. Let's try to be even more simple, okay? Yes, let's try to be even more simple, है ना? So 2 by 6, what is 2 by 6? 2 by 6 is ideally 1 by 3, 1 by 3. And if I write 2 by 8, then what is it? 1 by 4. Tell me, as per mathematics, whenever you see that the denominator is bigger, don't you think that this should be your smaller fraction? This will be your smaller fraction, am I right? Am I right? Yes. So does this become my limiting reagent? BF3 becomes my limiting reagent, right? BF3 becomes my limiting reagent. So that's it. Now what I have to do? Now I know that 8 BF3, 8 coefficient is 8. So 8 BF3 will give me 6 LiH. 8 BF3 will react with 6 LiH. Yes, that is the question. The question says that. Yes? Okay. 6 LiH, absolutely right. Now I want to find out what if I take 1 mole of BF3. If I take 1 mole of BF3, then what is the amount of LiH that I require? That means that 1 BF3 will react with 6 by 8 LiH. From here, from this equation, I figured this, right? Now, because the question is asking me 2 moles, so I want to find it out for 2 moles. Now, for 2 moles, what will it be? 6 by 8 into 2. 6 by 8 multiplied with 2, right? Right, everybody? Which will give me 1.5 LiH. That means that I want to find out how many moles of B2H6 can be produced. So, 2 minus 1.5 will give me the answer, okay? 2 minus 1.5 will give me the answer, right? Got it, guys? Now is this clear? Shall we go to the next topic or the next chapter? Shall we go to the next chapter? Yeah? Yes or no? Yeah. Okay, so redox reaction. Now, redox reaction ideally is very simple. Okay, we all know what is redox reaction, isn't it? We all know that in redox reaction, there is a part that is oxidation and there is a part that is reduction. Now, what is oxidation, my dear student? The oxidation part is basically loss of electrons. When you lose electrons from any species, that's your oxidation. And reduction is basically the gain of electrons. Whatever you are gaining, any species, whatever they are gaining, that's your reduction. Yes, that's your reduction. Now, what is oxidizing agent? Acceptor of electron. That agent or that species that accepts the electron, they are called as the oxidizing agent. Yes. And that species that reduces, that species that donates the electron, we call them to be as reducing agent, right? We call them to be as reducing agent. This is very clear, very simple. And we have learnt it a lot in our junior grades, isn't it? In our junior grades, we have learnt it a lot, even like from 9th standard, 10th standard, we have learnt it, isn't it? Yes? Okay. Now, as you see from here, from this reaction or from this, you can understand that A plus B is getting reacted, right? Yes, I am making A plus B react, okay? So, A loses 1 electron and forms A plus, yes, and B gains 1 electron and forms B minus. So when A is losing electron and forming A plus, that means here oxidation is happening. Am I right, everybody? Yes? Am I right? Yes. But if B is gaining electron and it is forming B minus, then this is called as reduction. Yes? Yes, guys? This is called as reduction? Yes, absolutely. Now, if I take an example, let's say that if I take zinc, okay? If I take zinc and I take Cu2 plus, what is happening? What is happening? Zinc will become Zn2 plus, okay? Zinc is becoming Zn2 plus here, okay? It has lost some electrons. It has lost electrons, so that means oxidation is happening. Loss of electrons happened, that means this is oxidation. And Cu2 plus, what it is, this gained electron and formed Cu here. Do you see it was 2 plus? It had less number of electrons, but now it gained and it formed Cu. That means here reduction happened. Here reduction happened. Is that right? So do we understand, everyone? Do we understand this? We do, right? We do. Great. Okay. Now moving on from here then. Moving on from here. These are some tricky questions that we're going to do. Okay. Let's do some tricky questions. What is the oxidation number of Cr in CrO5? Can you do the calculation directly? Will you be able to do the calculation directly? What kind of a structure does it have? What kind of structure does it have? It has a butterfly structure, isn't it? Huh? It has a butterfly structure, everybody. So this is your Cr. Yes. So minus 1, minus 1, minus 1, minus 1, plus 1 here, plus 1 here, plus 1 here, plus 1 here. And this, what it will do is minus 2 here, plus 2 here. So what is the correct answer? What is the correct answer? It's right in front of your screen, guys. Absolutely right. The answer is plus 6. The answer is plus 6. Absolutely right. Very good. So CrO5 has in the Cr, oxidation number of Cr is plus 6. Yes. What do you have to remember? You must remember this part, guys. This part is the tricky part. You can't just write plus 4 or 5. In many places, what you might do is just cross multiply and say that, ma'am, 5. Now, just because of this butterfly structure, this double bond here, you have to remember that this is a tricky one. Okay, this is a tricky one. How do you find it? What did I do, bacha? See, no? Okay, one more time. CrO5 has a structure like this. Okay, O, 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 O and double bond O. Acha. Now, this bond, how is this bond forming? This bond is forming because it will lose one electron. This will lose one electron. Chromium will lose an electron. This will gain one electron. So this bond is forming, right? Yes. Now here once again, see, this will lose one electron. This will be gaining one electron. So another bond. Yes. How did that structure come? You are supposed to know the structure, Baba. Huh? 11th, 12th done, no? You are going for JEE. So some structures you will have to know. Hai. So once again, plus 1, minus 1, plus 1, minus 1. But this, minus 2 and plus 2. So 2, 1, 3, 4, 5, 6. That is plus 6 is the oxidation state. Understood? Yes? 5 minutes break. No, if I give you break, then you guys don't come back. I wish I could give you break, but yesterday also I saw that you don't come back. Many of you leave the class altogether. I want you also, today many of you are not here. I don't know why you guys are not here. Are you taking a break after your biology exam? Is that why you guys are less in number today? Just some of them. I can't tell you all. You know what? Just read the NCERT, this thing, no, once. Just read it once. I think that will be easier for you. Okay? Yes, solving silently. Very good. Chalo. Moving on. Oxidation number of H2SO5. What is it written? H2SO5. Calculate this. Let's see. Calculate this. I'll take a break for my voice, but you calculate this. Let's see. Don't be confused. There are two very confusing ones, two very confusing options. You tell me. +2, +6, +4, +8. Let's see. I'll show you the structure also in some time. Chalo. अरे वाह, शिवी एंड अरुण स्मार्ट, रियली स्मार्ट. रेक्स नाइट गलत हो गया, गलत हो गया. एग्जैक्टली, peroxide bond. वेरी गुड, वेरी गुड. अरुण स्मार्ट, well done. Not well done. Can't do. Chalo, let me show you the structure here. What is the structure? Yes, H2SO5. Rex Knight, you are right. Sorry. You are right. Arun Smart and who was the other one? You guys were wrong. You are right. Rex Knight, you are right. Yes. Ha. Chalo, so we will... This is what you have to be careful about. This part. This part is the tricky part. This part is the tricky part. A lot of students, what you do is, see, you will calculate everything and you will say that it is +8. That's what you did, no? That's what you did, isn't it? That's exactly what you did. That's why you found out +8. Nah, the structure, remember, see, here what will happen. How will this bond form? -1, +1, okay? This bond is forming because of +2, yes? This is again forming for +1. This is again forming for +2. So 2, 2, 4, 5 and 6. That's it. Why will you calculate this part? You will not be. This is not required. This is not required. Okay? Yes. Yes. These two are not required. You only need the closely knit oxygens here. So +6. That's it. Done and dusted? Done and dusted? Clap for yourself. Those of you who got +6, clap for yourself, everybody. Come on. Very good. Proud of you guys. Chalo, moving on from here. Now tell me. Calculate the oxidation number of P in the given structure. Who was it who wanted to find the valence factor? Bacha, do this. Do this. Let's see. Chalo, do this. Do this and tell me. The structures are given, so that's an easy one. If the structures are given, then you can do it very easily, isn't it? Go. Let's see. What do you think? What do you think? Tell me. Let's see. Do we find the answer? The answer is actually this, okay? +1, +3, +5 and +5. How? I hope you know this. I hope you know this. Very good, very good. Beyblade, Unnati, Shivi, Venkatram, Venkatram KS. Well done. Next question. Hey, this is easy. This has also come a lot of times. So tell me, MnO4- is a good oxidizing agent in different medium. Changing to MnO4-, which gives Mn2+, MnO4-2-, then MnO2 and then Mn2O3. Change in the oxidation number. Change in the oxidation number, okay? You have to tell the change in the oxidation number. Batao. Come on. You are the first. Very good, Kishore. Very good. Proud of you. Come on. Very easy. MnO4- to Mn2+. What is the oxidation state here? Then what is the oxidation state here? What is the oxidation state here? 2+. And then what is this? Where is this? Here. You have to figure it out. Very good, Shiva Priya Ganapati. Absolutely right. Yes, it is option C. So let's find it out. See, MnO4-, the first one here, it is in +7 state. Am I right? Yes. Let me write it with this. Here, this is in +7 state. Okay, this is +2 state, obviously. So +7 to +2 is 5. Correct? +7 to +2 is 5. Now, MnO4-2-, here, what is this? Here, what is it? Yes? Do we see it? It is C, bacha. It is C. Huh. Now, here what is happening? So, number is 5. Then, from Mn2 plus, it goes to plus 6 oxidation state. So, the change in the oxidation number, see, now this is 5, this is 1, okay. Then, here what happens is plus 6 to plus 4. So, it becomes number 3. Then, plus 4 to plus 3. So, it is 4, okay. It is 4. So, 5, 1, 3, 4. Option C is the correct answer. Very good. Very good. Well done. Moving on. Now let's find out the N factor of redox reaction. Is it different or is it the same? Is the same, guys. N factor, do you remember? We have done it, no? We have done it just now. Which chapter was it? Which chapter was it? Mole concept. The mole concept N factor, and this is same, okay? Yes, 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 Shaku. Yes, yes. With respect to 7, yes. Absolutely yes. Yes, with respect to 7. Huh. That's why. Plus 7 to plus 2, then plus 7 to plus 6, then plus 7 to plus 4, and then plus 7 to plus 3. Okay? Yeah, that's one. Yes. So what the mole concept N factor that we have done, it's exactly the same. N factor or valency factor is a term that is used in redox reaction. If you remember KMNO4 in acidic medium, KMNO4 in basic medium, KMNO4 in neutral medium, the one that we did, that's exactly the same thing. Yes, do I need to work harder and do I need to explain it to you again, or is that okay for you guys? Or is that okay for you guys? Whatever you have learned, that will work out for you. Do you want me to work harder again? Yes or no? Thank you so much. Okay. Now, calculate the N factor of Bi2S3 in the following reaction. You tell me Bi2S3 gives you Bi5 plus S. What's the answer? What's going to be the answer? Chalo. Do this. I hope you have a pen and paper, yeah? You are doing it on your own. This is the last revision. We are leveling it up, isn't it? We cannot give an excuse and think that it's okay if we are not able to solve. We are supposed to solve now. Okay, the answer is option D. How? Chalo. Here, Bi2S3. So, obviously, plus 3 minus 2. Cross multiplication. Yeah. Now, Bi here, it is given as 5 plus. And S here is in 0. Okay. So, that means that, what are we getting here? Why are there these? I have no idea what is happening here. Anyway, so plus 5 minus plus 3 is equal to, here what do you get? 2 into 2 is equal to 4. That is your N1. Then here, since we have 0, so 0 minus 2 is equal to 2 into 3 is equal to 6. That's your N2. Now, NF, how do we calculate the N factor? NF is equal to N1 plus N2, which is basically 4 plus 6, that is your 10. Huh? That's your 10. Okay? Is this clear, guys? This is clear? Clear? That's how we find it out. Okay? That's how we will find out the N factor. Nothing else. Easy. Easy peasy biryani is tasty. Hello, understanding or sleeping? Why so many of you said C? How did you calculate it? How did you guys calculate it, and how did you find it out to be C? No. C is not working out. It's option D. Okay. Calculate the N factor of FeC2O4 in the following reaction. FeC2O4 gives you Fe3 plus CO2. So once again what we will do is plus 3 minus plus 2 is equal to 1. Plus 3 minus 2, that means 1. N1. Plus 4 minus plus 3 is equal to again what? 1 into 2 is equal to 2 NO2, right? You basically same thing we have to do. Same thing we have to do. How we calculate this? Hey, look at the option. Look at the option, bacha. Plus 5 plus 3. Isn't it? Yes. 0 minus 2. That's how. How is this? Explain. Chalo, one more time, guys. Let's look at it. Let's look at it. है ना? So our reaction is Bi2S3, in which Bi is in +3 oxidation state, S3 is in -2. Yes. Now in here Bi is in +5 and S has 0, right? Yes. Abhishek, Shivi, understanding this much? This you understood? Now what we are going to do is, because here it is +5, product side minus the reactant side, okay? Product side minus the reactant side. So 5 minus +3, that means it is 2. Yes, it is 2. So 2 into 2, we have multiplied it. Now what we have done is, here we have multiplied it with 2, we are getting 4. Okay, we are getting 4. Yes, yes, okay, because of course Bi2S3, we are getting 4 is our N1. Makes sense? Makes sense, nonsense? Yes, bacha, I am posting this also, no? I will post it, don't worry. There will be DPP also. I'll give you daily practice also. Today you will get it. Yes. Now next is, see, here it is 0. So product side minus reactant side -2. What do we get here? So 2 into 3. Here there is 3. So 2 into 3, we are getting 6. Now 4 plus 6 is equal to 10. Is this easy? Now does it make sense? Chalo, I understood. You needed a little more explanation for n factor. Now is this clear, guys? Now is this clear? Yes? Great. Moving on from here, now tell me this question. FeC2, FeC2O4 is giving you Fe3 plus CO2. Tell me, how will you figure this out? Now you can tell me, based on whatever we did. Based on whatever we did, can we do this? Chalo, let's do this. So here again, see, in the product side +3, yes, +3 minus +2, okay, +3 minus +2, if we do, we will find 1, that's our N1, okay. Now here, what we will have, again in the product side, we will have +4 minus +3, which is equal to 1 into 2, multiplied it with 2, yes, multiplied it with 2, okay. That means we are getting 2, so that's our N2. So what is our NF? Our NF is N1 plus N2, which is basically our 3. That's our answer. Yes, that is our answer. Yes, got it? Clear? Got it? Awesome. Now, see, balancing a redox reaction, when you are balancing a redox reaction, it involves some steps, right? It involves some steps. So what are you going to do? You can either balance the atoms, you can balance the charges, you can balance the electrons which are lost and gained. Yes, oxidation number method you can use, or half reaction method you can use, right? Or half reaction method you can use. So let's see, how can we balance this reaction in acidic medium? MnO4 minus plus I minus, Mn2 plus I2. Think about it, guys. Think about it. What can we do? Acha, let's complete this, then we will take a small break. Okay, let's complete this, then we will take a small break. Very easy. So MnO4 minus plus I minus Mn2 plus I2. Chalo. You know, easier way would be I2. Let's write 2I. Hai na? Let's write 2I. So 2I minus I2, that means here 2 electrons are there. So or what you can do is, you can also find it out, right? From here to here, what is happening? 5 electrons, isn't it? 5 is the difference, right guys? 5 is the difference, isn't it? This one was at +7 oxidation state and it is going to +2 oxidation state. From +7 to +2 it is going. Yes, +7 to +2. Before doing that H2O thing also we can do this. Yes, and here you see that 2 electron, the 2 happened. So can we just multiply it with 5 and 2? Yes, can we just multiply it with 5 and 2? We can do that. So this 2I, this 2I which gives you I2 plus 2 electron, you can multiply it with 5. Multiply it with 5. Or what you can do is, and what you have to do is, the reduction half is MnO4 minus plus 5 electron gave you Mn2 plus, this you multiply it with 2. Yes, this you multiply it with 2. So that means what you are getting is 5 into 2, so 10, 5 into 1 coefficient I2, so you are getting 5 I2, and then 10 electron here, okay, 10 electron here, which now here what you are getting is 10 electron, 2 into 5, 10 electron, then what is happening, 2 into MnO4, so 2 MnO4 minus, which gives you 2 Mn2 plus, right? That means my complete reaction will be, what is my complete reaction, guys? My complete reaction will be here 10I minus plus 2 MnO4 minus, yes, this is what I'm getting, plus, now it is saying, it has said that in the question, acidic medium, that means H2O will be there, that means H2O has to be there, right? So because H2O is there, that means H plus ions are going to be there. So let me write 16H plus, yes, which is giving me 5I2 plus 2Mn2 plus 8H2O. That's my balanced reaction. Clear hai? Clear hai, guys? Yes or no? Yes or no? Tell me, yes or no? Do we understand this or not? Crystal clear? Arun, I just explained, bacha. Give it a little bit thought and try to understand. Give it a little bit thought. Awesome. Okay. Now you guys want a break? You guys want a break, but I see a lot of students have already gone. Not gonna give you a break, yeah. You want a break or no? Sure, I'll give you a 2-minute break. A 2-minute break. It is 3:17 now. Yes, you can see it for NEET also, bachan. No worries, you can watch it for NEET also. Chalo, it is 3:17 now, so I think I'll meet you at 3:20. 3:20. I'll meet you. Chalo. Go, I'll come from washroom till then. Break is over, everybody. Chalo. Call up your friends. See, so many of you left. That's why I did not want to give you a break. Now you won't come back. A good time to leave the class, no? I knew it. Chalo. Come back, everybody. Go, call up your friends. Let's do this. So here is a question. Can you all hear me and see me? Audible and visible? No, guys? Am I audible and visible? Yes. Okay. Alright, let's do this. So when copper is treated with a certain concentration of nitric acid, nitric oxide and nitrogen dioxide are liberated. That means produced. Okay. In equal volumes according to the equation. Your equation is coefficient X, Cu, Y, HNO3. That gives you CuNO3 plus NO plus NO2 plus H2O. What are the coefficient? The X and Y coefficient, what are these? What are the coefficient? Bata. Yes, why Shivi? I am also not understanding. I don't know why. Chalo, let's do this. How are we going to do this? Now we can see that Cu from here it goes to Cu2 plus oxidation state, right? From Cu it goes to Cu2 plus. And here we see that HNO3 is gaining one electron, H gaining one electron and HNO3 is giving you NO2 plus H2O. What happened to this? Huh? Where is the pen? Huh. Yes, this is our equation 2, this is our equation 1. Now here again we see that NO plus 2H2O is forming, this is our equation 3. Now if we multiply this equation, multiply equation 1 with 2, and you add the equation 1, 2 and 3, what will you get? You will get 2Cu, 4H plus 2HNO3, giving it 2Cu2 plus NO2, NO plus 3H2. Or we can write it as, yes, 2Cu plus 6HNO3 will give us 2CuNO3 plus NO2 plus NO and then 3H2. That means our coefficient X and Y are 2 and 6. Okay. That means our coefficients are 2 and 6. Right? Is this clear? Will we be able to solve this kind of questions? Will we be able to solve this kind of questions? Yes or no, people? Yes or no? Yes. Okay. What will be the value of X, Y and Z in the following equation? H2C2O4 plus X H2O2, which gives you Y CO2 and 7H2O. Whoa, you have to find 3 values here. That is X, Y and Z. 3 values you have to find out. Batao, what will you do? Okay. So the half reaction for oxidation is very easy. H2C2O4 CO2. H2C2O4 is giving CO2. Hai na? Now, if you balance the carbon atoms on both sides, what will happen? This is C2O4, so we will balance it as 2C, 2CO2. Okay. Now, if you balance the hydrogen atoms on both sides, then what will happen? H2, there is H2, so that means we will need 2H plus. Yes, we will need 2H plus. If we balance the charge on both the sides, then what will happen? H2C2O4, which is giving you 2CO2 here, and then 2H plus you have written. You will also have to balance the charge, so 2 electrons balanced. Yes. Now, the half reaction or the reduction, the other half reaction or the reduction side is H2O2 is forming H2O, right? H2O2 is forming H2O, yes. So, balancing oxygen atoms on both sides, here there is oxygen O2, now here only one oxygen is there. So, to balance we will add a 2 here, right? Now, balancing the hydrogen atoms H2O2, yes, and here also it is 2H2, but that means there are 4 hydrogen atoms here, yes. So, we still need 2 more hydrogens, so we will add 2H plus. Now, let's balance the charge. Yes, now let's balance the charge. So, what we will have to do is H2O2 plus 2H plus, we are adding 2 electron here, it becomes 2H2O. 2H2O. Yes, done, it's balanced. Now, if we add this half reaction and this half reaction, what will we get? We will be getting H2C2O2 plus H2O2, which is giving us 2 CO2 plus 2 H2, and this, and this is our balanced equation. So that means what is our x, y, z? X is equal to 1, x is equal to 1, y is equal to 2, and z is equal to 2, right? See, y and z. Yes, x is equal to 1, this is equal to 2, and this is equal to 2. Correct, guys? Understanding, everybody? Understanding? Let's start our last chapter, that is chemical equilibrium, shall we? Let's start our last chapter. Yes, Robin, absolutely right. Absolutely right. Chalo, let's start with chemical equilibrium. Guys, those students who left in between the break, please call them. Once again, explain. Kajal, would you mind just like rewinding it a bit and watching it? Because this is very simple. You just had to what you... And why are you... See, one more thing that I will like to tell you is, why are you balancing the charge? Because here you added H plus, right? So 2 positive charges are extra. If there are 2 positive charges, this is not possible, because in a balanced chemical equation, the charges, everything has to be balanced, right? So if there are 2 positive charges extra, to balance it, you are adding 2 electrons. Okay? You are adding 2 electrons so that it becomes balanced. That's it, bacha. That's it that you did. All you did was just left and right, first half and the second half, the oxidation part and the reduction part of the equations, you just had to balance it. That's it. You just had to balance it. Okay? Alright, understood? Great. Now let's do chemical equilibrium. Now in case of chemical equilibrium, what are the different types of chemical reaction? We have learnt it in really younger classes that chemical reactions can be of 2 types. One is reversible and one is irreversible. Now if it is reversible, then we know that the reaction can go forward and it can come back backward also, right? Yes, it can come back backward also. For example, these reaction can easily take place in a closed vessel. Forget about that. So CaCO3 in solid form becomes CaO plus CO2. If you add this, you will again get CaCO3, isn't it? So it can go forward, it can come back backward also. But in case of irreversible reaction, the reaction which has happened once, if it has proceeded once, it will not come back again. So the examples are precipitation, neutralization. Once it has neutralized, you can't bring back the acid and the base from it, right? That cannot happen. Now let's talk about the equilibrium. What happens at the equilibrium state? Yes, the states of system at which all the measurable properties of the system, pressure, temperature, color, mole, density, they all become constant. Everything becomes constant, okay? That's your equilibrium state. Now in equilibrium, it can only be attained in the reversible reaction. Equilibrium only happens in reversible reaction, which are again happening in a closed vessel. Okay, all right. Now the rate of forward reaction decreases and the backward reaction increases, and both becomes equal when equilibrium is attained. Obviously, common sense, absolutely common sense, right? Now the concentration of reactants, it decreases, and the concentration of products, it increases, and both becomes constant when equilibrium is attained. Of course, once again, makes sense? Yes. Now, if you look at this graph, guys, if you look at this graph, initially, see, this is the rate of the reaction, yes? Basically, what is exactly happening to the reaction? If you look at this graph, do you understand that in the beginning, the reactants are more? In the beginning, the reactants are more, so the rate is very fast, and it is coming down like this because the reactants are getting used up. The reactants are getting used up, so it is trying to come down here. Now, when you look at the product side, here what is happening? In the beginning, it is very less. It has not formed yet. At T0, it has not formed yet, right? Now, when it goes up, slowly and steadily, as the reactants are getting, as the reactants are reacting, the products are forming and it meets. So that means from this graph, what we understand is at this point, when the reactant curve or the forward reaction and the backward reaction are meeting, that, my dear student, is my equilibrium. That is our equilibrium. Do we understand this? Do we understand this, everybody? Yes or no? Is this clear? Is this clear, guys? Equilibrium is attained. Absolutely right. Absolutely right. Okay. Yes. Now let's move on and let's understand. So here is something called as the laws of mass action. Okay, the laws of mass action. Let's understand this. Basically, the rate of reaction is directly proportional to the product of active mass of reactants. Okay, activity. Here comes another term, activity. So the rate of reaction is directly proportional to the product of active mass of reactants raised to the power of their stoichiometric coefficients. And as you can see, my dear student, as you can see here, A is my activity. Yes, A is my activity. So activity of A, what am I doing? I'm raising it to the power of N1. N1 is my coefficient, isn't it? N1 is my coefficient here. Yes. Is this my N1? Is this my coefficient? N1 is my coefficient. So what did I do? A to the power N1. Here, A to the power N2. Isn't it? Isn't it, everybody? Understanding or not, guys? Are we clear on this? Are we clear on this? What is this? What this statement is saying? Yes? Yes. Absolutely right. Absolutely right. But basically what I mean is, what is activity? What is activity? Here it is written, no, active mass. What is activity? Come on. I'm going to give a little bit of break to my voice. See, activity is basically the active amount of the reactant. Okay, what is activity? Activity is essentially the active amount of the reactant. Okay, so active mass of the reactant. That's exactly what is written. Active mass of the reactant. Yes, and that means that what we have done is raised to the power of the stoichiometric coefficient. These are the important part of your definition. Yes. Now let's take a look at it. So how are we calculating the R of forward, R of backward? See, RF is directly proportional to A of capital A. This is my first reactant raised to the power N1. My second reactant raised to the power N2. And here in the backward reaction, what am I doing? C, yes, this is my first product raised to the power N3, second product raised to the power N4. So RF becomes KF. What did I do here? I have to remove this, equating it to a proportionality constant, which is KF AA to the power N1 multiplied with AB N2. For backward, same thing. I have done KB proportionality constant, AC to the power N3, AD to the power N4. So here what I have to do, RF is equal to RB. RF is equal to RB. Now again, these reactions we will take and we will equate it. These reactions, logical hai na? This is logical, isn't it? I'm just explaining it to you, but if you look at it carefully, then you find out that it's very logical. Obviously, I have equated RF is equal to RB. That means this and this will also get equated. This and this is also getting equated. Right or wrong? Right or wrong? Yes. So that means that at equilibrium, KEQ, yes, what is happening? KF by KB is equal to, same thing again, just do this, just do this. See, here, from here and this here. So you will be getting, this is my formula. This is all that you have to remember. Yes, let's do a problem, you will be able to understand any which ways. Chalo. Let's see that for gaseous reaction, okay, concentration as well as pressure are defined. For a gaseous reaction, obviously concentration and pressure are defined, no? Otherwise, who knows what shape, what things gas can do, right? So here, if you see HI, this is in gaseous form, this is in gaseous form, this is in gaseous form. So what am I going to do is, I will calculate Kc is equal to H2 I2 divided by HI square. Yes, what did I do? See, quotient, here quotient was 1, here quotient was 1. Coefficient, sorry, quotient it seems. Here coefficient was 1, here also coefficient was 1, but here it is 2. So, HI to the power coefficient square. Making sense, guys? Making sense? Yes? Yes, everybody? Now, because it is a gas, we will also have to do the partial pressure thing, right? We can also do the partial pressure thing. So, what am I doing? Kp is equal to PH2, Pi2 divided by again PH1. HI square. Yes, guys? Or no? Hello? We understand this, yes. Now, if I take another example, okay, let's take the example of aqueous form. Here is our aqueous, yes, see, you see the state changes? State changes, this was gaseous, this is aqueous. So here it is forming NH4 plus, OH minus, aqueous. So that means here what am I going to do? I will only take Kc. Only Kc will be fine. So Kc is NH4 plus, OH minus, but here is there any coefficient here? No coefficient. So simple NH4OH and Kp is equal to X. है ना? Yes? Yes? Very good. Chalo. Now let's see another example. Okay, let's see another example. Yes. So homogeneous gas reaction. If it is a homogeneous gas reaction, then what are we going to do? If it is a homogeneous gas reaction, that means, see, take a look at it. What is homogeneous gas reaction? 1 mole, 1 mole, 2 mole. This is what you are getting. So, Hi square divided by H2 and I2. Kp, partial this thing, yes. So, Phi square divided by this thing, okay. Now, delta Ng, okay, what will you get? Ngp, that is product, Ngr, that is reactant. What are you doing? 2 minus 2 is equal to 0. So, this is your homogeneous. But take a look at the same composition. Exactly. What is homogeneous gas reaction? Arun, I just told you. I had just told you. Before I went into the reaction, I told you what is homogeneous gas reaction. Anyway, figure it out in some time. Chalo, here what do we see? We see that PCl5 in gaseous form. It is giving you PCl3 in gaseous form and Cl2 in gaseous form. Yes. Do you see something here? Do you see any difference in this two? Do you see any difference in this two? What is happening? What is happening? Here what you're getting is 2. In the product side there is 2, but in this side it is only 1. Yes? Understand the difference? Arun Smart, see, 1 mole is giving you 2 moles. Here, 1 mole, 1 mole, 1 mole. 1 mole is giving 2. So, in the product side, now it becomes heterogeneous. Yo, understanding? Yes? Now, did you get it? Homogeneous, heterogeneous, understood? Great. So, here PCl3, Cl2, this will become PCl5. This should be PCl5. है ना? So, that means that PCl3, okay, there's a mistake here. There's a mistake here. So, Ng of product, Ng of reactant, 2 minus 1 gives you 1. Okay, gives you 1. Delta Ng can be. Mindy facts, let's not get there now. Wait up. Heterogeneous. Okay, now let's come to heterogeneous. What do you see again? CaCO3 solid. There is some gadbad, yeah. Anyway, CaCO3 solid. This is solid and this is gaseous. Look at it. Look at it. Everybody, focus up. Focus up. Here, gaseous, 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 gaseous. But here, solid, solid, gaseous. Yes? Do you see it? Now what we are going to do is, so Kp is PCO2. Only gaseous we are considering. And this we will consider as 1. Okay? For the solids, we will consider it to be 1. So, Kc is just CO2. That's it. And delta Ng is equal to 1. Okay? Now, here also this is solid, this is gaseous and this is gaseous. Okay? So, we will again do this. Kp is equal to, see, PSO3 and then PO2, 3 by 2. Why 3 by 2? It's written here 3 by 2. So, delta Ng will be equal to 1 minus 3 by 2. That means minus 1 by 2. So, Kc will be SO3 divided by O2 to the power 3O2. Okay? Alright? Yes, Rex Knight. No problem, bacha. Take care. Watch the session later. Yes? Understanding, guys? Understanding or more explanation is needed? Heterogeneous gaseous reaction, homogeneous gaseous reaction. Do we understand this? Yes? Arun, all clear? Yes, okay. Chalo, moving on then. The relation between Kp and Kc. See, if we really get into this, okay, if we really get into this and we try to explain everything, like I said, the session will not end on the right time. So what I'm going to do is I'm going to quickly show you the formula, okay. I'm going to quickly show you the formula and let's start to solve some more questions, okay. So units of relation between Kp and Kc. See, Kp is equal to Kc RT delta Ng, okay. And here Kc is equal to mole by L to the power delta Ng. Here again Kp is equal to ATM. ATM is, you know what is ATM, no? To the power delta Ng. Yes, that's it. These are our relation. These are our relation. You can just take a look at it, write it down if you want to. Otherwise, anyway, we're doing some questions now. So let's find out. We will be able to find it out from the question. So the question is, write the Kp expression for the following in terms of Kc. Write the Kp expressions for the following in terms of Kc. Chalo, try doing it, guys. Sai, Darshan, R, try doing it. Come on. The first reaction is H2 gaseous, H2 gaseous state plus I2 gaseous state will give you 2HI gaseous. Batao. Come on. These are actually from the example that we have done. Let's try to do it. Chalo. So delta Ng for the first reaction will be, my dear student, as you can see, there are 2, right? Coefficient is 2 here. And here I can see that 1 plus 1 is equal to 2. So 2 minus 2 is equal to 0. That means that my Kp expression in terms of Kc will be, we know that from this formula, Kp is equal to Kc RT to the power delta Ng. That means that Kp is equal to Kc RT to the power delta Ng. That means that Kp is equal to Kc because this becomes 0, right? This becomes 0, right? Understood. Moving on. Second one, see, PCl5 gives you PCl3 plus Cl2. That means here what is happening? This is 1 and here is 1. Here is also 1. So 1 to 2 it is forming. So that means 2 minus 1 I will do. 2 minus 1 if I do, I will find 1. 1 is my answer. From this same reaction, Kp is equal to KcRT to the power delta Ng. What will I get? I will get KcRT. Yes. Is this clear? I will be getting KcRT, right? Yes. Very simple. Next one, N2 plus 3H2 is giving you 2NH3. That means here it is 2 and here it is 3 plus 1, 4. So that means that 2 minus 4 is equal to minus 2. Now what will be my Kp value? My Kp value in terms of Kc will be KcRT to the power delta Ng. That means minus 2. Minus 2. Now are you understanding? Now are you understanding what is this relation? This is how the questions might come. Okay. This is how the questions might come. Moving on. Here again let's do it. See. 1, 1 and 1. Yes. No. This is solid, this is solid, this is gaseous. So 1 minus 0 is equal to 1. Now that means that Kp is equal to KcRT once again. Yes. Is the same thing. Is the same thing. Very good, Mohit the Greek. Very good. Do we understand all of these? We have, isn't it? We have. Very good. Very good. This relation is clear? This relation is clear? Well done. Now, next question, guys. Kp for the reaction N2 gaseous plus 3H2 gaseous, which gives you 2NH3 gaseous, is 49. Yes, they are giving you the value of Kp. The Kp value is given. So now you have to calculate the value of Kp at the same temperature for the reaction. For the same temperature, you have to calculate it for another reaction, which is NH3, will give you half N2 gaseous plus 3H2. That means this is my forward reaction, and for this the backward reaction they have told you to find the Kp. Chalo, yes, I'll give you 2 minutes. Go ahead. I'll give you 2 minutes. I'll stand aside from the screen so that you can solve it. Go ahead, guys. Go ahead. Let me know once you are done. I see that Calvin and Robin are done. Anybody else? Okay, now can I show you the solution? Let me show you the solution. Chalo. So here N2 gaseous plus 3H2 is giving you 2NH3 gaseous. And it is written that Kp is 49. These are all given? Yes. Now 2NH3, N2 gaseous plus 3H2. So what do? My Kp dash. I want to differentiate between the two Kps, right? This will be 1 by Kp, which is 1 by 49. So 1 by 49 or let's take this NH3 half N2 gaseous, this is my reaction, plus 3 by 2 H2, this is my reaction, yes. So Kp double dash is equal to 1 by 49. If I do a root over here, if I cannot do a root over, I'll just write half, which is becoming 1 by 7. Absolutely right, you guys. Absolutely right. Give it up for yourself. Clap for yourself, everybody. Clap for yourself. Very good. Amazing. Moving on. Next question. The equilibrium constant Kc for the reaction is N2 gaseous plus O2 gaseous gives you 2NO gaseous at temperature T is 4 into 10 to the power. At temperature T is 4 into 10 to the power minus 4. The value of Kc for the reaction NO is equal to half N2 gaseous plus half O2 gaseous at the same temperature is. Chalo, try to do this. Try to do this. I'm hoping you'll be able to do this also. If you could do this, the previous one, you will be able to do this also. Come on. Calvin is done. Anyone else? Very good. Okay, let's do this here. So we have our answer here as well. Same thing you have to do, guys. Same way you are solving, isn't it? The very same way if you solve, you can see that here you will be getting C, Kc dash root over 10 to the power 4 divided by 4 is equal to 50. Okay. So that means our answer is option D. Option D. Thank you, Satvik. Thank you so much. We understood this. Moving on now. Thermodynamics of equilibrium. Okay. Thermodynamics of equilibrium. Guys, it's written that delta G is equal to delta G naught plus 2.303 RT log 10 Q. This is actually in any temperature. In any temperature, in any condition. Okay, let's write in any condition. This is the case. But if it is equilibrium, this Q will become K. Yes, this reaction quotient, it will become K. Okay. So that means that if this becomes K, that means that my delta G naught, there is a big derivation that's there in your book. We are not getting into it. I'm just going to quickly explain it to you. So that means my delta G naught will be minus 2.303 RT log 10 K. Yes. From this reaction, do you see? Yes, you can definitely write this, Kalpana. Otherwise, I'll anyway give you the PDF, right? So you can check it there. I'll anyway be giving you the PDF. So I think right now, if you just listen to me and if you try to process all of this, it will be easier for you. I guess, whatever, your wish. If you want to write, you can write down. So thermodynamics of equilibrium, our reaction is delta G is equal to delta G naught plus 2.303 RT log 10 Q. Yes, where Q is my reaction coefficient. Isn't it? Now what did I tell you? I said that that is in any condition. At equilibrium, my Q will become K. Yes, my Q will become K. That means my delta G, this will become 0. If this becomes 0, if this becomes 0, then what will happen? Then if I just reshuffle this reaction, if I just reshuffle this equation, this is what I will be getting, isn't it? This is what I'll be getting. Do I make sense or no? Do I make sense or no? Come on, guys. Let's finish it quickly. It's already about to be 4. Another half an hour or so, we should be able to finish it. Okay. All right. Okay. Now, what is degree of dissociation? See, degree of dissociation ideally is, imagine you have a class of 30 students. Now, out of the 30 students, do you think that everybody, the moment the teacher goes out, I don't think that all the students will start making noise, right? It's not ideally the case. What is the ideal case? The ideal case is 10 students will come up and start shouting. Where is the rest of the students? Maybe they will be sitting, they will be reading something or something else they will be doing, right? Yes, isn't it? The same way, it is equal to the number of moles dissociated out of each mole of reactant. Mitra, it's written, na baba. Delta G is Gibbs energy, delta G naught is standard Gibbs energy. Yes, yes. Some will put their head, absolutely right. So what is my degree of dissociation? My degree of dissociation, I can find that the number of mole dissociated divided by number of moles taken. Like I said, out of 30 students that I have taken in the class, out of that maybe only 10 of them are dissociated and they're like, wah, they're doing all of that. Isn't it? Makes sense? Degree of dissociation, that's it. Very simple, very easy. Very simple, very easy, everybody. Very good. Absolutely. Now let's come to the problem solving again. So the degree of dissociation of SO3 is alpha at equilibrium pressure. Now you have to find that alpha at equilibrium pressure P0, okay, or P0. So Kp for 2SO3 gaseous gives 2SO2 gaseous plus O2 gaseous. You have to find the Kp. Batao guys. You have to find the Kp. Chalo, I'll give you 2 minutes again. Solve it, solve it, solve it. Done, done? Let's try to solve it. Okay. Let's try to solve it here. See. So our reaction that is given is 2SO3 gaseous, 2SO2 gaseous plus O2 gaseous. Now at T0, T0 I have A. This is 0, this is 0. Obviously my reactant is this much. But my products have not been formed yet. At T equilibrium, I know that it will be A 1 minus alpha. Yes? You are not getting the answer? No problem, Kalpana. Let's try to understand this here, okay? It will be A 1 minus alpha. Yes? Of course. Correct? And here it will be A alpha. Okay. If you are not understanding this, A 1 minus alpha, let's understand this, bacha. Here, let's say that my product formed is A alpha. And I know that here this was A. So that means whatever is my reactant left will be A with A alpha. Yes, A with A alpha. So that means I can just take I can just take the A as common and I can write this in bracket 1 minus alpha. Yes. Can I write this? Can I write this or not? Yes guys, basically what I'm saying is this is A minus A alpha, isn't it? This I can write it as A 1 minus alpha. Correct? Understanding? Very good. Very good. This much you have understood. Awesome. Okay. And here it becomes A alpha by 2. Okay. Alpha by 2 because this. Okay. Alpha by 2. Yes. Got it. So my total mole at equilibrium is A 1 plus alpha by 2. Yes. Yes. Now my PSO3 is 1 minus alpha divided by 1 plus alpha by 2 from here. Yes. And then P naught is 2 1 minus alpha divided by 2 plus alpha into P naught. Okay. So PO2 is equal to alpha by 2. Again, just solve this guys. Just solve this. Okay. So what will be my Kp? My final Kp after all of these reactions will be this. Okay. All of these will be this. Now, yes. Here what do we have? I have the same thing. For PSO2 I have this. For PSO3 I have this. For PO2 I have this. Now from these, this and this is my Kp value. This is my Kp value. From here I am getting that the answer is this. That means it is this. Isn't it? Yes? Yes, that means we have to do this. See what is it? Alpha to the power 3 P naught divided by 2 plus alpha 1 minus alpha square. That means same thing. P naught alpha to the power 3 divided by 2 plus alpha 1 minus alpha square. Understanding? Yes? Looks a little complicated, but once you try to do it, it's very simple. Very simple. Just from these reactions, just from this and this. I got my Kp value. Kp formula you already know. We have just done it some time back, isn't it? Yes? Do we understand? Kishore, did you understand? Try to do it in your notebook once. Try to do it in your notebook once. I think the calculations will look easier if you try to do it once. Moving on. Assume that the decomposition of HNO3 can be represented by the following equation. 4HNO3 gaseous gives 4NO2 gaseous plus 2H2O gaseous plus O2 gaseous, and the reaction approaches equilibrium at 400 Kelvin temperature and 30 atm pressure. At equilibrium, partial pressure of HNO3 is 2 atm. Calculate the Kc in mole by L cube at 400 Kelvin. You have to use R is equal to this value. Chalo, batao. You have to use R is equal to this value. Ha, Robin, that's also something that you can do, but I guess this is just simpler to explain, hai na? That was just simpler to explain. If I would have asked you to assume something else, then all the students would have been a little more confused. Chalo guys, chalo. All right, let's do this. So we have our P total is PHNO3 plus PNO2 plus PH2 plus PO2, right? As per this reaction. As per this reaction, this is our P total. So that means that PNO2 is equal to 4PO2 and PH2 is equal to 2PO2 from the same reaction. Same reaction. Make sense? Yes? Okay. So that means that my P total is equal to PHNO3 plus 7PO2. Yes? Yes? PHNO3 is equal to plus 7PO2. Huh? Now 30 minus 2 is equal to PO2 into 7 and PO2 is equal to 28 by 28 by 7 because 30 minus 2, 28 by 7 which is equal to 4 here. Yes? It's equal to 4 here. How, ma'am? What how? Acha, chalo. Let's try to do this again. We have 4HNO3 gaseous, 4NO2 gaseous plus 2. That means that my PHNO3 is equal to, my P total will be equal to, PHNO3 plus 4PO2 plus 2PO2 plus another PO2 that is there. This PO2 I haven't considered. Yes. So 4 plus 2 plus 7. Yes. 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 30 minus 2 is equal to PO2. Whew. Started sweating and all. I was thinking that how can I'm teaching wrong or what? No, this is correct. This is correct. Yes, this is correct, guys. I'll have to edit this one. Otherwise, all the other students who watch it later, they will get confused. Anyway, so PO2 is equal to 28 by 7 is equal to 4. Kp is this, as you can see. Here there is 4, so P4NO2, then multiply it with PH2O, PO2, P4HNO3. And the same thing, this follows, and then the correct answer is obviously 32. Yes, the correct answer is 32. All right. Yes. Hey, don't get confused like this in your exam, huh? Just like how I did right now. Don't get confused like this in your exam. Anyway, moving on from here. What happened to this? Okay. Now this is not changing. Great. Okay. Ionization constant and ionic product of water. Okay. So if we have to calculate the ionization constant and ionic product of water, yes, how will we do it? According to Arrhenius concept, a very age-old name that we have always heard, Arrhenius concept, we come to this. So according to Arrhenius concept, we know that H2O will become H plus and OH minus, right? Now what will it be? So Ki will be Ka is equal to Kb is equal to Kd, right? So that means that my same thing, guys, same whatever we have followed till now, same thing here also, H plus aqueous, OH minus aqueous, but H2O is in liquid. Do you see this? Do you see this? Yes. So my Ki is multiplied with H2O liquid and H plus aqueous, and here is OH minus aqueous, same thing. Yes. Now my ionic product Kw is equal to H plus OH minus, from here is equal to 10 to the power minus 14. Yes. Again, we will not get into the derivation so much. So Kw is equal to Ki H2O liquid. Yes. Now if temperature increases, Kw also increases. Temperature increases, Kw also increases. So Kw is equal to Ki into 55.55 at 25 degrees Celsius. If it is 25 degrees Celsius, then it will be 55.55. Okay. Yes. So pH plus pOH. pH plus pOH is equal to pKw. 14 for an aqueous solution at 25 degrees Celsius. So that means our pKw is equal to 14 for an aqueous solution. Yes, do we understand this? Do we understand this? pKw is 14, okay? pKw is 14, isn't it? Yes? Okay. Moving on. What just happened to this? Okay. Now let's take a look at strong monoprotic acid and base. If there is a strong monoprotic acid and a strong monoprotic base, then what will happen here? Mixture of two strong monoprotic acid, obviously H plus monoprotic acid and base. We know that for monoprotic acid is H plus, monoprotic base it is OH minus. So that means N1V1 plus N2V2 is divided by V1 plus V2. Now mixture of two strong monoprotic bases. If it is bases, then obviously we will be finding OH minus. So once again, same thing, N1V1 plus N2V2 divided by V1 plus V2. Now, if the mixture of strong monoprotic acid and strong monoprotic base, and let's just imagine that my N1V1 is more than N2V2. If my N1V1 is more than N2V2, then what will happen? Then this is what will happen. That means H plus is what I have to find out. If N1V1 is greater than N2V2, then H plus, this is what I find out. Okay. But if N1V1 is lesser than N2V2, if N1V1 is lesser than N2V2, then it becomes OH minus. Then it becomes OH minus. Yes. And I have just shuffled it. See, N1V1 minus N2V2. Here what I have done is N2V2 minus N1V1. Understanding or not, guys? Ma'am, Tamil Nadu State Board exam is going on. What we can do? Nothing, bacha. You study both of them. While you're preparing for board, make sure that you also prepare for your competitive exams. Don't leave them. Whatever is your focus, focus that. Focus on that. Okay. Chalo. Moving on from here, pH calculation of different solutions. Let's do. Okay. One more time. Now, if we have a weak monoprotic acid and a weak monoprotic base, just some time back we saw strong monoprotic acid and strong monoprotic base. Here what we are doing is weak monoprotic acid and weak monoprotic base. So pH will become half pKa minus log C. Somebody was telling me that in the chat box some time back only, right? And pOH is equal to half pKb minus log C. Yes. So the mixture of weak and strong monoprotic acid is, as you can see, H plus C1 plus C2A, where C1 is the concentration of the strong acid and C2 is the concentration of weak acid. If the mixture is of weak and strong, then this is what we're going to do. If the mixture is of two weak monoprotic acids, both of them are weak, then what we will do? C1 Ka1, C2 Ka2, root over obviously and H plus. If it is weak polyprotic acid, weak polyprotic acid, not mono, it is poly. So H plus will be Ca1 plus Ca1A2. Okay. So here concentration of acid, C is concentration of acid, A1 is the degree of dissociation, or alpha 1 is the degree of ionization of H2A and alpha 2 is the degree of ionization of HA. Okay. All right. That's what it is. That's what it is. Moving on from here. Relationship between Ka and Kb for conjugate acid and conjugate base pair. What do we understand from this? If we have HCl, that becomes H plus plus Cl minus. So this is the conjugate base. This is my conjugate base and this is my conjugate acid. है ना? है ना? Yes. So what do I get? Same thing, everybody. What we have been always doing, and this is what we get. Okay. Our final result becomes this. Final result becomes this. Yes. Yes. You know that, Robin. Very good. Again, now salt hydrolysis. Oh my God, this chapter has just so many things. So salt of strong acid and base, no hydrolysis. So pH will be equal to 7. Salt of a weak acid and a strong base. Once again, remember that weak acid part, it had half. So half pKw plus pKa plus log C. If the salt of a strong acid and a weak base, same thing again, half pKw minus pKb minus log C. Remember the signs, plus plus here, minus minus. Salt of weak acid and weak base is equal to pH, pH is equal to half pKw plus pKa minus pKb. Yes. Moving on from here, buffer solution. I would like to skip this. I'm tired. No, let's complete it, guys. Let's complete it. We will not skip anything. So for buffer solution, what is buffer solution? Solution which resists change in pH on dilution or with addition of small amounts of acid or alkali. So acidic buffer solution, a weak acid and its salt with a strong base. Yes? Okay. Now pH is lesser than 7, obviously acidic buffer solution. Example, you have CH3COH plus CH3CONA. So our pH will be equal to pKa plus log of conjugate base divided by acid. That's it. 2 formulas, that's it. Basic buffer solution, pH is greater than 7, obviously. So NH4OH plus NH4Cl, that's my example. And POH will be pKb plus log conjugate acid divided by conjugate base. Yes. Just the opposite of this is what I am writing here. Moving on. Solubility and solubility product, guys, you know in your book, yes, you must have seen that it's a long derivation, but you don't have to remember all of this. What you have to remember is just this much. Just this much. Solubility product of salt of the type. If I take a salt of this type, then what will happen? Then my KSP will be equal to, this is what I will do. Yes. Like example, AgCl. I have taken AgCl. Yes, what is it giving you? Ag plus aqueous and Cl minus aqueous. So my KSP is Ag in the bracket, Cl in the bracket. That means my KSP is S to the power 2. Why? And what is S? What is S? S is the solubility of AgCl, or S is the solubility of any salt that you take. Whatever salt that you take of this type, yes, for that what you will do is S to the power 2. Solubility of AgCl is this. Okay. Solubility of AgCl is this in mole per liter. Mole per liter. Yes, getting it, guys? Getting it? Chalo. Moving on. Now KSP, let's do this. Condition for precipitation. What will give us precipitation? What will give us precipitates? Let's take a look at that also. So KSP, solubility product at equilibrium concentration, and QSP is ionic product at any concentration, right? Remember Q and this thing K? Remember that equilibrium formula we did? Q is for any condition, whereas K is for equilibrium. So that means if KSP is less than QSP, what will it happen? Precipitate will form. Yes, you will be getting a precipitate. But if your KSP is greater than QSP, more salt will dissolve. If your KSP is equal to KSP, then it means that it is at equilibrium, obviously. Obviously. This condition we have already studied some time back, isn't it? We have already studied this some time back. Great. Now solve this, guys. Solve this, everybody. Chalo, solve this. If solubility product of Zr3PO4, 4 is denoted by KSP and its molar solubility is denoted by S, then which of the following relation between S and KSP is correct? Chalo, guys. You know all the formula, everything was done. Chalo. I'll give you 2 minutes. Shall I solve it then now? Let me solve it then. Here, for AXBY, if my salt is of this kind, if my salt is of AXBY kind, then as I just read you, as I just taught you, XAY plus YB X minus. That's my reaction type, yes. So my KSP will be AY plus to the power X and BX minus to the power Y. Now the compound that is given to me is Zr3PO4 4, isn't it? So for Zr3PO4 4S in solid form, what will I get? I will get 3 Zr4 plus in aqueous form and 4 PO4 3 minus aqueous. So here it is 3Sm, here it is 4Sm. Yes. That means my KSP value will be Zr4 plus to the power 3, as I have just done this, see, Zr4 plus to the power 3, yes, and PO4 3 minus to the power 4 from here. So my KSP becomes 3S to the power 3 and this becomes 4S to the power 4. When I multiply this, 3 cube multiplied with 4 cube will give me 6912S to the power 7. Yes, how do we solve them? How do we solve this? This multiply this cube, this 4 times. Once you have done this, then 3 plus 4, 7. So S to the power 7. Or my S will become KSP divided by 6912 with the result that I have just got to the power 1 by 7. Yes, to the power 1 by 7. Okay. Why 1 by 7? Here it is 7, na? Here it is 7, so 1 by 7. That means that the relationship between the molar solubility S and the solubility product KSB will be S is equal to KSP divided by 6912 to the power 1 by 7. That means that my solution, this is correct. Alright? Yes? Will we be able to solve it? I'll be giving you more practice questions also in the Telegram channel. So don't forget to join in the Telegram channel. Moving on from here now, 20 ml of 0.1 m H2SO4 solution is added to 30 ml of 0.2 m NH4OH solution. The pH of the resultant mixture is pKb of NH4OH is equal to 4.7. Let me give you this as a problem for your homework. Let me give you this as a homework. I'm not going to show you the solution here. Okay, I'm not going to show you the solution. Consider this to be a homework. In fact, if you want, you can note down the question. Note down the question, guys. Note down the question and do this as a homework. This is your homework question. Okay, note it down. Note it down, guys. Come on. Okay. Now, tell me something, because I have seen that very less students joined today. Tell me something, is 2 o'clock is the right time for you, or do you want me to change the time and take it in the evening? You tell me. If it is not benefiting the majority of you, then I guess we should change the time. So please tell me, is 2 o'clock right time for you? Is 10:30 in the morning as Shreyas sir is taking for you? Is that the right time for you, or do you want us to take classes in the evening? You tell us. Or you know what, I think we will do a poll. I think we should do a poll in this thing. 2 o'clock is okay. Then why such less students joined? Was there a paper today? Did you guys have a exam today? Two is okay. All right. But then I would, evening you want to self-study. Exactly, that's what we thought of. But then very less students are joining, no? Bio exam. Acha. ठीक है. Okay, bio exam you had, no problem. Then 2 o'clock only we will keep it. So from tomorrow again at 2 o'clock I will see you. Tomorrow again I will see you at 2 o'clock with 3 more chapters. Yes. with 3 more chapters, and I think organic will also soon start. Organic also we will be starting soon. Yes, GOC, hydrocarbon, that's what we are studying tomorrow if I'm not wrong. You can check out the community post. Also, your notes, your short notes, your daily practice questions, all of it will come on the Telegram channel, my dear students. So please join the Telegram channel so that you can get all of these, okay? So that you can get all of these. And with this note, everybody, thank you so much. I'll see you tomorrow again. I hope that you understood, all your concepts were clear from these 3 chapters. Like I said, I used to hate this session. I used to hate these chapters when I was younger. But I hope that I was able to at least, do some justice. And I know very, very, very well that Wasim sir had taught you very well these 3 chapters. So I'm not very sure if I could justify that or not, but I tried my best. If not, I think watch the older sessions that are available in the session. Chemistry short notes you are not getting, I'll be providing you with the PDF, and I will just ask around that what Shreyas sir is actually providing it to you so that I can also do the same thing, okay? Just after this session, let me call him and find out, and I will also provide you that. Don't worry about it, okay? So thank you so much. Don't forget to subscribe to the channel, and see ya. Bye-bye.